Hello everyone. Today we are going to learn a new protocol of our IEG products, the PROFIBUS Essentials. To start this course, please study Serial and Ethernet Essentials first. Some basic knowledge may not be introduced or explained in this lesson. This course is open for all the technical service engineers. This lesson is going to introduce you the PROFIBUS essential knowledges before learning most IEG products. In this lesson, you will learn the basic knowledge of PROFIBUS technology. The PROFIBUS essentials will cover the origin and organization, and the certificates awarded by PI. Then we will go to the industrial communication topology to get the whole picture of the PROFIBUS. And after understanding the whole picture, we will go to the details based on the OSI 7 layers, from the physical layer, MAC layer, to user interface and application profile. The last part is the state machine of a PROFIBUS device, and then we will have a summary in the final section. The process field bus, or we call PROFIBUS, is a standard protocol for field bus communication in automation technology. The PROFIBUS was created in 1987 in Germany. The Siemens was the initial promoter. PROFIBUS and PROFINET International (PI) were then established to maintain and publish PROFIBUS and PROFINET protocols. Eventually, PROFIBUS became a widely accepted protocol. According to the statistics, more than 31 million devices were using PROFIBUS by the end of year 2009. Since there are so many devices that using PROFIBUS in the world today, interoperability between devices from different manufacturers is absolutely necessary. And having the certification issued by official PI test laboratories ensures the communication with devices from other manufacturers. And as you can see, a lot of companies, as shown above, have passed this PI certification, and of course, most our products is certified as well. For general industrial communication applications, there are different levels to describe different types of devices. At the actuator or sensor level, the actuators and sensors collect the numbers of the local environment and then transmit them to an I/O device. At the field level, the distributed peripherals such as I/O devices or drives communicate with the automation systems via an efficient real-time communication system. The PROFIBUS meets these requirements and offers a transparent solution for manufacturing as well as for process automation. At cell level, the programmable controllers such as PLC and IPC communicate with each other. The information flow requires large data packets and a large number of powerful communication functions. And smooth integration into company-wide communication systems such as intranet and internet via TCP/IP and Ethernet are important requirements. After learning about the industrial communication and know that it uses PROFIBUS protocol because of efficiency and real-time communication, let's learn more about the PROFIBUS standard based on the OSI model. In this figure, you will see that the PROFIBUS only uses Layer 1 and Layer 2, as well as the user interface. Layer 3 to Layer 7 are not used. This streamlined architecture ensures fast and efficient data transmission. Above Layer 7, PROFIBUS defines DP functions available to the user, and the system and device behavior of the various DP device types are specified in the user interface. Starting from the next slide, we will introduce PROFIBUS standard from physical layer to user interface. There are three kinds of media which can be used for PROFIBUS. the twisted pair wire, fiber, and infrared. RS485 transmission is the transmission technology most frequently used by Profibus. The application area includes all areas in which high transmission speed and simple, inexpensive installation are required. The transmission rate is from 9.6 kilobits per second to 12 megabits per second, which can meet most cases. MBP, or Manchester Code and Bus Powered, according to IEC 1158-2, is the special physical media used for Profibus PA devices. The Profibus PA device offers field bus solution for the process industry, which needs bus power. And all the Profibus PA devices only work with 31.25 kilobits per second transmission rate. The last two media, fiber or infrared, are used for specified environments. For example, high electromagnetic interfaces, which uses fiber, or wireless requirement, which uses the infrared. For layer 2, the fieldbus data link defines two things. The Profibus uses master-slave network, and the masters working in a token passing method. The master-slave network means there are Profibus master and Profibus slave devices. Generally, the master device will generate a write or read command to write data to a Profibus slave or read data from it. Since the Profibus application allows multiple masters, which master is decided to be the one to talk? Easy. There is the token, which will be passed among the masters. The master which has the token on hand can talk. Others will keep silent. As the figure shows here, the first master gets the token and then sends the request to the slaves under it. After it completes a cycle, it will pass the token to the next master. The second master will do the same thing and pass the token to the next one. This is how the token passing method operates. Above layer 1 and layer 2, the DP communication profile is designed for efficient data exchange at the field level. The central automation devices, such as PLC, PC, or process control systems, communicate through a faster serial connection with distributed field devices such as I/O, drives, valves, as well as measuring transducers. And data exchange with the distributed devices is mainly cyclic. So, DP version 0, also called basic functions, defines the cyclic data exchange between masters and the slaves. To do the data exchange, it defines the GSD files for a master to control different slaves made by different manufacturers, which we'll discuss more in the next slide. There is another option for DP version 0, the diagnostic message. When communication fails between a master and slave, the slave will send a diagnostic message to the master to inform the master of a communication error. The DP version 1 makes it possible to transmit acyclically, read and write functions as well as alarms between master and slaves parallel and independent of cyclic user data communication. And with DP version 1, it meets the requirements of even complex devices, which often have to be parameterized during operation. Nowadays, the DP version 1 are mainly used for the online operation of the PA field devices by means of engineering tools. The failsafe and alarm functions are further analysis tools for finding an error when communication stops. With DP version 2, the isochronous operation mode is used when real-time positioning is required. The basic principle is that all Profibus devices on the network are clock synchronized with the master using a global control broadcast, enabling simultaneous data acquisition from all slaves with microsecond accuracy. The slave-to-slave communication function allows Profibus slave devices to listen to the actual values of other slaves and use these as set points. A slave device which provides its actual values to other slaves is called a publisher. Devices which listen to the actual values of other slaves are called subscribers. In addition, there is a feature for DP version 0 communication called plug-and-play configuration. What is it? We import the GSD files of these slaves into the host. Then the host will download the system configuration into the PLC, including these GSD files. So, automatically, the PLC can operate these slaves through the features and the parameters which are defined in these GSD files. There are two categories of a Profibus master. The Class 1 master is the main controller of a Profibus application. It follows a state machine, which we will introduce later, to work on a Profibus network. It will control the slave and acquire data from the slaves most of the time. It's the main master that provides remote data for monitoring or analysis. The Class 2 master is the engineering station or monitoring or supervisory system. There is no state machine for a Class 2 master, so you can check the status of a specified Profibus slave for the current status data via a Class 2 master anytime. A Class 2 master also can control a Class 1 master, for example, change the state machine of a Class 1 master. After introducing the physical layer to the user interface layer of Profibus protocol, and how a master or slave device works, we are going to introduce you the application profiles. The application profiles are designed for specified applications, which includes DP functions and the transmission technology for special environment and the requirements. For example, here we compare Profibus DP and PA. The first column is about applications they are used for. Profibus DP is used for factory automation and Profibus PA is for anti-explosive, security, oil and gas fields. Meeting different usage and for different environment requirements, Profibus PA uses power over RS485 bus with low speed, and Profibus DP chooses high speed bus which can up to 12 megabits per second. We already know there are two categories of DP masters. But what about the relationship between a master and a slave? How do they work together to acquire the data from I/O, or we say sensor actuator level devices? In this flowchart, on the right hand side, we can see that after we power on a DP slave, it will go to the parameterization state. In this state, the DP master will connect to this slave and set the parameters that will be used for communication later. When it's done, the slave will move on to the I/O configuration state. In this state, the master configures the I/O modules it will read or write on the slave. If everything is okay, the slave will move on to the data exchange state, which means the master and slave are going to exchange the data of the I/O modules cyclically. For a DP master, after power on, it will go to stop state first. In this state, data transfer is not permitted between the master and the slaves. Data transfer to other masters in multi-master system is allowed, which also means that this master has already joined the token ring in a multiple master topology. The bus parameters set has been loaded successfully in order to get into stop state. In clear state, the master is able to read the input data from the DP slaves. The master forces the outputs to the slaves to be in a safe state. Parameterization and configuration checks are possible in this state. In operated state, data transfer is possible without any restriction. This data transfer is cyclic, for example periodically. The input values are read from the slaves and the output data are written to the slaves. When at operative state, there is a service called SDN service, send data with no acknowledge. Then the master can control the whole groups of its slaves. This permits an event-controlled synchronization, where all slaves set their outputs simultaneously, the sync mode, or update their input data simultaneously, the freeze mode. After today's introduction, there are 4 things to be remembered. 1. The PROFIBUS protocol is an efficient real-time communication system at the field level for the distributed peripherals to communicate with the automation systems. 2. The PROFIBUS is a master-slave network. For a network with multiple masters, it relies on token parsing method to decide which master can talk. 3. With the GSD configuration file, a PROFIBUS master can control slaves produced by different vendors. 4. Application profiles define specified DP functions and the transmission technology for specified application. For example, PROFIBUS DP or PROFIBUS PA. Thank you for your time and congratulations to you to finish this course. Remember to take the quiz of this lesson to check how much you have learned.